So this is going back to the earlier thing we were talking about with the teachers and the grades they give. So not only do I want to figure out what the center is, and what wins out of all those measures of center, the one that we use the most often, you should know this because it's the one that you know how to do the best, the mean. Right? It's the one we use the most often. There are situations where you want to use a different one, but the most frequently used one is the mean. So I want one more number, and this number, I want this number to capture an idea of the spread of the data. So let me give you guys a few things here. So here's 3 sets of data here. What you got, Jeff? Make it number 5. So let me ask you something real quick. If I have 5 numbers that average to be 5, do you know anything about the numbers themselves? You know shit about the numbers. One of the numbers could be negative 18 billion, as long as another one is about 18 billion, right? So then it kind of averages out. But if I know that 5 numbers average to be 5, I know exactly what they add up to be. How do you find the average of 5 numbers? You add them up and divide by 5. So if the answer I get from that is 5, what do they add up to be? 25. Because what's divided by 5 is 5? 25. So if I have 5 numbers that average to be 5, they have to add to be 25. So do you see how I made all these average to be 5? That's freaking 5. No work required. If I make that go down by 2, I make that go up by 2, they still add to be the same thing, still 5. If I make that go down by 1, I make that go up by 1, they still average to be 5 because they still add to be 25. You guys see that? A little bit? Okay. Alright. So all these averages are fine. Let's say these are populations. So be careful about the word population. I know we normally think population means big, but population just means all, right? So I'm going to say these are 3 populations. My population could be 1. It could be, what's his name? Tom Hanks on the island. Population of the island. So at least for a little while. So the mean here's 5, the mean here's 5, the mean here's 5. All right. The first idea we might have for figuring out how spread out my data is I think somebody said it earlier, we already have a number that sort of does that. It's the range. The range, right? So what's the range of this data? Yeah, this data is not very interesting. The range there is 0. And what's the range of this data? Oh shit, that's looking good so far. How do I know it's looking good? Because it's different. The data sets are obviously different. This is obviously more spread out than that is. So it's good that that number got bigger. Yes, but which one of these sets of data is more spread out? Good. This one. Right? Isn't this one repeat its mean? It doesn't get very far away from its mean, its middle, except for these 2, right? Whereas this one gets away from its middle everywhere. Let me make sure you guys really understand that, because this is huge. This data set is definitely more spread out than this one. Is it spread out a lot more? No. But the number that I use to measure how spread out it is has to be a little bigger for this data set. So why is the range not a good candidate anymore? Because the freaking range of this is 4. So screw the range. Range no good. Go ahead. Too bad for your range. Okay. Can you do it right? All right. So this is where you see, like, this is what another reason why I love stats is you can really see how we construct a formula to tell us what, hey, formula, I want you to tell me this. So you're going to see the sausage being made here, but that's good, right? Because that's what we use math for. We say, here's some math. I need to know this. How do I make the math tell me this? Tell me, math, tell me. Okay. So, I'm trying to lead you in a certain direction. because there are a few different ways to think about this, but there's one way that's the way that we settle on. So it kind of makes sense to talk about spread as how far from the middle you get on average. So on average, how many data points got away from the middle at all in this data set? Just 2 of them, right? 3 of them are the average. This one, 4 of them got away from the average. So that's one reason why I should think that this is going to have a larger spread, right? So it's all about comparing each data point to the average. How far away is each data point from the average? Okay, maybe. Okay. So I'm going to write like this. I'm not even going to do this. What do you think the number I'm going to come up with, what do you think it's going to say about this? It's going to say this is 0. Because how much spread is there? 0. And if it doesn't say the spread is 0 here, I'd throw the shit out. So that's no good. But thankfully it would say it's 0. So let's look at this one. This is a little more interesting. Stay with me now. So the first thing I want to calculate, based off of what I just said earlier, is for each data point, I want to see how far away it is from the middle, from the mean. So in symbols, how do I figure out how far apart 2 numbers are? What operation do I use? Subtraction, 11. So I would take the data point minus the mean. And why am I using the Greek mu? Because these are populations, 11. They're not very big populations, but, give them a break. So what would I get here? What's the mean again? 5. So here I get -2. 0. 2. All right. By the way, I've got a handout I'm going to bring tomorrow. On one side, it's a completely worked out problem. On the other side, it's going to be a problem you're going to work out yourselves. So we're just stepping into this stuff today, and then tomorrow, first thing, we'll just hammer this stuff out. The rest of tomorrow's class is going to be devoted to review for the test, after we get this stuff handled out. Now, how do I find the average anything? I want to find the average blank. I want to find the average money that you guys make in a week. Well, how would I figure that out? I would first have to add up everybody's money they make in a week, and then divide by how many people there are, right? So if I want to find the average distance from the mean, I would find out all the distances from the mean, add them up, and then divide by how many there are, right? Do you guys notice something that's bad if I try to do that here?
You get 0. Cancel it.
You will always get 0 here. Does that make sense? Because the mean is in the middle value-wise. You always have equal amounts negative as positive. So, good job, Jeff. You took us down to a dead end. This column will always sum to be 0. And I want to continue to make you guys understand this notation. I have a bunch of those, don't I? X minus mu, where are they? There they are. And what does this symbol tell me to do with them? Add them all up. Alright, maybe. So if I had a problem, real quick, a little side note. If I had a problem that said, it gave me some x's, and it said, what's the sum of x squared? You first have to, if you cover the sum symbol, it tells you what you have to make a column of, because then you're able to add them. So I'd have to figure out a column of x squares, and then I can add those up. Good job, Jeff. Alright, maybe. So we're going to see a lot of formulas that have this symbol in them. To figure out what you want to make in this table, you cover that up and say, I need to make a bunch of those, and then I can add them up. Alright, now, coming back to this. I said a word that should hopefully make you guys think about a function in algebra and math. This isn't the true distance, is it? If you're 2 feet away from me, you're not -2 feet away from me because I turned around, right? Negative 2 feet would be like your image. Yeah, Quaid. Right? Reference? No? No. All right. So one way to take care of this is to take the absolute value, because absolute value is distance. That's why it always comes out to be positive. There are several reasons why we don't use that more often. We do use it. It's called the standard error. But we don't use it as often as this other thing. And one reason is, does anybody remember what the absolute value looks like if you graph it? It looks like a V. Does it? Would you want to be in a plane that flew like this?
No.
No, because what's going to happen here? You're going to die. I want something that actually does that turn more gently. So what does that look like? That's right, parabola. And that would be not an absolute value, that would be doing what? Squaring. 11. So one way to kill the negative is to take the absolute value. Another way to kill the negative is to square it. So that's the way we're going to go. If some of you guys have taken calculus and beyond, you could actually understand the math behind why we do what we're about to do, and it's related to this kind of thing. But I'm just going to assume that not everybody does. But at least it makes sense that this is an option I can take to kill the negatives. Because what's the main problem right now? It's always going to add to be 0. Well, that's no good. So I want to kill the negatives by squaring them. So then what do I get here? 4, 0, 0, 0, 4. So what does it mean I'm going to have to do at the end? Before I'm done, I have to eventually take the square root. Because if this is like dogs that people own, this is square dogs or something. What the hell kind of cubist Picasso shit is that, yeah? Get away from me. I see a little... Alright. Now, let me go back. I really want this to make sense. I want to find the average distance from the center. We had to square to kill the negative. So now I want to find the average squared distance. So how do I find the average blank? I find a bunch of blanks. Okay, I got them. I got a bunch of squared distances from the mean. I add them up and I divide by how many there are. That's how I find the average anything. You find those things, you add them up, divide by how many there are. And the spread, it only makes sense that it should be the average distance the data points get from the mean. If they on average get further away from the mean, the spread is bigger. Let that make sense. That idea is what's going behind this work here. So what do you get when you add these up? Good. And what's the symbol I would put for what we just did? Cool. So, we're almost there. You're still going. I can't believe it. Okay, good. So the symbol we use, I want the symbol we use for what we're about to do to have a square on it to kind of remind me that I have to take a square root before I'm done. Does that make sense? Because we know we have to take a square root. We squared everything. We these weird square dogs. I don't want to do that to the dog. So the symbol we use for what we're going to get here is lowercase sigma. It's like a fat R. Let's talk about drawing this for a second. Start at the belly, go around for the little head there, right? Depending on how I feel, I either get a fat one or skinny one. Somebody's just going to make it R. Please don't do that, because R means something else. Find that out later. So this is called the variance. Oh shit. And the variance is the average squared distance. So how do I find that again? I keep saying it. You add up the things and divide by how many there are. So this formula would be the sum of these distances divided by how many distances? Yes?
What's the name of the variance, the symbol for variance again?
It's lowercase sigma.
It's lowercase sigma?
Yeah, so this is uppercase sigma, and that's lowercase sigma.
Thank you.
And the reason we use that lowercase, remember the reason we use uppercase sigma is it's the Greek letter S, and this was sum. So somebody guy's like, but when you square root it, you get what's called the standard deviation. So once I square root this, this is the population standard deviation. Oh shit. So again, the bigger that number is, the more spread out your data is. The smaller that number is, the less spread out your data is. Makes sense? It's like a city. It could be sprawled like crazy, or it could be one of those cities where you're driving, you blink and you missed it. Or there's a gas station. Okay, so what do we get when we actually do this formula? What goes in the top? Here's where people really mess up, and I almost can't blame you, because you're so used to plugging shit in. The thing you got to realize is, I know what this entire thing is. What is this? 8. So what do I put for this whole thing up there? Freaking 8. I don't put stuff there. I don't put stuff there. That's what was going on for each row. Now I know the sum of that business is 8. I just put an 8 up there. And on the bottom, of course, I'm going to put 5, because there's 5 numbers, right? N is the number of data points. Bless you. That is the variance. So, of course, how do I get the standard deviation? You just take a square root. It's not somehow related to 4. Be careful. It's be about 1.265. Okay, sure. 265?
Yeah.
For standard deviation, for me, you have to go out at least 3 decimal places. Oh shit, let me say that again. For me, for standard deviation, I want you to go out at least 3 decimal places. Yes, ma'am.
I missed the part where you said where you got N from.
Oh, N is just always the number of points in your data, in your set, in your sample, or population. Alright, so you guys take a minute. This is the last thing we're going to do today. 5 minutes. Let me see, this should be very quick. Do what we just did for this data set. You guys realize how you've already got most of the information done, right? The only difference between this and this is 4 and 6. You should be able to do that relatively quickly, hopefully. Do what we just did for this data set. What would you predict its standard deviation? Should it be bigger or smaller than this? It should be bigger because it's more spread out. Make sure you guys understand. If I just make this a 4 and this is 6, pretty much just keep going with it, what we've already done, right? Where are we at? Well, that did come out as an irrational number. So, apparently not. You just round it to 3 decimals. Yeah. Is that cool? So what's this sum going to be? 10. So now this is 10 over 5. 2. So now this is square root of 2. 1.414, yeah. Which is bigger than the 1.265 we just got, right? Not really.
Okay.
You know, it's sort of like, you know, saying you live about square root of 28 miles away. You know, I want that to be something I can work with other numbers. Yeah.
If you want the plus and minus, compensate for this.
Oh, be careful. I'm squaring this here and then taking a square root. I've already identified that I want the positive root, and it should kind of make sense. If this is an average distance from the mean, it definitely can't come out negative. So I understand you're worried about when you take a square root, you put plus or minus normally, but this is understood it cannot be negative. I need to use a positive one or else it wouldn't make sense. All right, that's plenty for today. So, yeah.
Is that the variance symbol there, or just a skinny one?
That's the variance symbol, sigma squared. This is the standard deviation.
Oh, the standard deviation.
Yeah.
So
Yeah, just without the square. Without the square.
oh, okay, yeah. That's what I was asking.
Oh, it's always high minus low. So here, the high and the low are the same. Here it's 7 minus 3, and here it's 7 minus 3. Yeah. Oh, thank you. Oh, sure. So tomorrow we're going to construct a formula sheet when we start doing the review. Oh, okay. Oh, yeah.